Here's one of the many engaging projects that I gave to my students, and this was kind of an end of units project after they took the test, and it was over linear equations. They were learning how to graph and the very basics, so just learning how to graph lines and the hard work that they put into it. Because they became inspired, so did I. So I made a few videos about graphing absolute value equations. We had already started that unit, so they should have already known how to do that. But how to graph hyperbolas and lines, they had already known. Parabolas, they didn't quite know yet. Circles and ellipses. And hyperbolas, if they really wanted to get very advanced. If you look at how tedious the work that they put into it, that this particular student put into it. This one was made by the top student at the Harmony at the time. His name is, well, I shouldn't say his name, but these are actual ellipses, and that's not an easy equation for someone to wrap their head around. So at a 9th grade level, he was able to produce this. So this is an ellipse here, and these are circles, and this is an inverted ellipse, which is also not easy, but he figured all this out. And hopefully my videos guided him, but this student was so determined, this student who was at Thin School of the Harmony, that he probably put a lot of time into it. He also won a can of Pringles because he won the contest. So I made it into a contest. So that might have motivated them more. This student obviously liked the Simpsons, so she replicated a picture from here onto here. But there's no coding. I asked them to put coding on, but it's still a good example. This student was the second highest student at a previous school where I worked, and he did a really good job. These are ellipses. This is an inverted ellipse. It looks really good. This is a parabola, and he put restrictions to cut the parabola off. He put a small horizontal line, and I'm not sure if it's supposed to be a butterfly, but whatever it was, the coding was what I was most interested in. So he also coded it so that it was able to fly. So I was very impressed with what this student did, the amount of time he put into it too. I remember this student, it seems like a lifetime ago, but she was a dog lover, so she obviously made a dog. But if you look at the extent of the coding, an inverted parabola, inverted parabola, inverted parabola, find circles, circles. And all I expected them to do was just kind of experiment with the formulas that I gave them. And they really took them, they turned a math project into an art project and kind of overlapped the two. But the formulas are very intricate to make something that looks relatively simple, but really a lot of work was put into that one. The top music student in the school, an overachiever, obviously. She made 2, he won. Always overachieved. This is during when the Olympics were going on. And really liked what was done there. This is all I wanted them to do. This one is very simple, and I still gave the student an A. But the other students wanted to maybe outdo each other. They get very competitive. These are absolute value equations. All you have to do is put a negative in front of the absolute value sign, and that inverts the graph. So if you get an absolute value, every time you put a negative number into the equation, it always comes out positive. So you always get these V's, but they put a negative number in, which I thought was clever. The sun's here. These are linear equations. They drew these linear equations with a very steep gradient, and I like it. It looks like a river coming in, and it's kind of pretty. I kind of want to print it out and put it in my classroom. I'm not sure what country this flag represents, but that's okay. It leaves room for creativity. Kalina was one of my top students, and this is a sine wave, and she had a tutor, so I think she learned well beyond the extent of what the class was, but still, she did a great job. Parabola, which is a quadratic equation. She used restrictions to cut it off. Linear equations here to make the flag. Vertical line, which x is equal to whatever that is, 65 it looks like. And then, yeah, she did a great job. And then my creation, which I made, as a joke between me and you. But I told the class that I think that this is the best one. Genius.